Okay, welcome back to another Just the Basics Semester 1 Calculus worksheet. This is like our third or fourth example of these, but thought I'd put this one out on video. We've got a negative, but otherwise we've dealt with this function before, so we are going to find the first derivative. We've got a first function of x times a second function of x, product rule. We need the plain old first function times the derivative of the second. E to the is e to the, but we have to treat the baby, and the baby is negative 4x, so times negative 4. So that's first function times derivative of second plus the derivative of the first function, just negative 5, times the plain old second function. There's product rule. Let's just clean it up a little bit. This would give me a 20x e to the negative 4x minus 5 e to the negative 4x, and I'm interested when that equals 0 because that's where our maximums and minimums could occur when the slope is 0. I'm going to factor out a 5 and an e to the negative 4x, and I get 4x and minus, factored out the 5, factored out the e to the negative 4x, 1 equals 0. If a number times a number times a number equals 0, one of them is 0. 5 is not 0. E to the negative 4x cannot be 0, but 4x minus 1 could be 0 when x equals add 1 divide 4. Okay, so our first derivative in factored form, I'm just going to jot it down here. We've got it as 5 e to the negative 4x times 4x minus 1. It is 0 at 1/4, and let's check signs elsewhere. Number bigger than 1/4, perhaps 10. I put in 10, 5 is positive. Put in 10, e to the negative 40th is positive. Put in 10, 4 times 10 minus 1, 39 is positive. Positive times positive times positive. We're positive this direction. Put in negative 10, 5 is positive. Put in negative 10, e to the 40th is most definitely positive, but 4 times negative 10 minus 1, negative 41, is negative, which means our graph goes down, levels off, goes up. Therefore, we have a minimum. X coordinate is 1/4. The graph decreases from negative infinity until we get to 1/4. Decreases from on the interval negative infinity to 1/4, and then increases from 1/4 forevermore. From 1/4 to infinity. We do not appear to have a relative maximum. Okay, second derivative. For our second derivative, and I don't even know which way is easier or harder. I could use this form or I could use this. I think I'm going to go up and use this. We're going to find the derivative of 20x e to the negative 4x minus 5 e to the negative 4x. We're going to find its derivative. First derivative, give us our second. So once again, we have a function of x times a function of x here. So to find the derivative of this, I need product rule. That is first function times derivative of the second, e to the negative 4x times negative 4, treat the baby. That's first times derivative of second, plus derivative of first function, 20, plain old second function, e to the negative 4x. And then I'm left with, that's product rule on this first term. I still have minus the derivative of this, minus 5, derivative of e to the negative 4x is e to the negative 4x, treat the baby, times negative 4. So let's clean this up. Negative 80x e to the negative 4x plus 20 e to the negative 4x plus another 20 e to the negative 4x gives me negative 80x e to the negative 4x plus 20 apples, 20 more apples, 40 of these apples, of which I'm going to factor out negative 40. You could factor out 40, but I'm going to factor out negative 40, get my first term to be positive. I'm going to factor out an e to the negative 4x. They both have that. Negative 40 times I need a 2. I don't have an x, I need an x. Negative 40, to get a minus into a plus, I need a minus. The 40 is factored out, the e to the negative 4 is factored out, we just have a 1. So, second derivative, negative 40 e to the negative 4x times 2x minus 1. That is 0 when either negative 40 is 0, never. When e to the negative 4x is 0, never. When 2x minus 1 is 0, that happens when x equals add 1 divide 2, 1/2. I'm going to put that relative to this 1/4, it would be to the right of. Second derivative is 0. Now, let's put something bigger. Let's put in 10. If I put in 10, the first term's negative. Second term's positive. Third term, put in 10 and I get 21, or 20 minus 1, 19. So I've got a negative times a positive times a positive, negative. Put in negative 10. I've got a negative. Put in negative 10. This term's always positive. Put in a negative 10 and I get negative 21. So I get negative times negative. We're back to positive here. Okay. So again, this is our slope. This measures our concavity. So we are concave up. We are concave down here. And we have an inflection point at 1/2 where the concavity changes signs. We're concave up from negative infinity until we get to 1/2. We're concave down from 1/2 to infinity. And we've got all of our answers here. We just need to build a graph. And I'm going to build this, I'm going to build it down here where we have a lot of information, but we're going to get some stuff from up above. So to build the graph, maybe the first thing I would do is look at our original function. I think I'll put it here. F of x equals negative 5x e to the negative 4x. That's our original function. I would get the point by finding f of 0. F of 0 equals negative 5 times 0 e to the negative 4 times 0. But since we're times 0 here, f of 0 is 0. We got a point right here. And then I'm going to consider end model behavior. In other words, what happens when x gets really big? And this isn't even really big. Let's consider f of just 10, something to the right of 1/2. F of 10, I would get negative 5 times 10, negative 50, e to the negative 40th, or on e to the 40th. So what's going on there is we get a negative divided by a positive. We're going to get negative, but 50 divided by e to the 40th already is virtually 0. So we're basically getting negative 0. I know that's kind of an oxymoron, but negative, we're getting closer and closer and closer to 0 from the negative side, which implies we look something like that. Now let's take a look at our zone here. Kind of interesting to do. Our zone, by the time we get way out to the right, should be rising. It is. Should be concave down. It is if we're getting sucked into that 0. So I like that. Let's go to the left. If I put in, let's go f of negative 10 here. F of negative 10 would give me positive 50. Now let's do that again. Positive 50 times e to the 40th. That's just massively huge, and it seems to me as the further left we go, the bigger our number is going to get dramatically, which implies we're going to end like that. Take a look as we go to the left. Once we get to the left of 1/4, our graph is going down. Yep, it's going down, has negative slope, and concave up. So I kind of like that. I think we are going to look something like this. I might piece some things back together shortly. Interesting things happen at 1/4 and 1/2. So I'll go 1/4, 1/2. I'm going to put a 1/2 right here. At 1/2, the concavity changes from cupping down this way to when I start cupping up, and at 1/4 we hit that minimum value. And then we're cupping up. So here we go, cupping up from negative infinity until 1/2, cupping down after, going down from negative infinity to 1/4, going up after that. So there we have it. Hope that's helpful. Let me know if I can help.